Okay, so we're live. Welcome, Ben. Welcome to Northernlands3, and thanks for joining us.
Hey, thanks for having me.
That's okay. That's okay. What we'd like you to do is just tell us a little bit about your fantastic work at OpenSAFELY, and also about the your ambition for your review of data in the NHS. And then we'll have a little bit of a chat. Yeah.
Good. Hey, thanks. Tell me, how long do you want me to talk for?
About 12.5 minutes.
I can do exactly 12.5 minutes. Great. All right. Well, look, hey, thanks for having me, and apologise for being unshaven. I thought I'd get time to shave before this. It's not really a live event. I mean, it's a live event, but I
was expecting more lockdown hair from you as well, actually.
Do you know, I've noticed, it just happened very recently, a lot of men discussing each other's hair, and I think it's because people are doing their own, and now it combines aesthetics with engineering. All right, so let me tell you about OpenSAFELY. Well, first, a sort of background, because people may not know. Although you may know me from my showing off activities, like writing bad science and things like that, I'm a doctor. I trained in medicine at Oxford and London, then trained in psychiatry at the Maudsley, then trained in epidemiology at London School of Hygiene and Tropical Medicine. And then 5 years ago, I came here to Oxford to work on building a team which is now called the Data Lab. And we're quite unusual in that we are a truly mixed team of software developers, clinicians, and traditional academic researchers. And we take large NHS data sets and we turn them into academic papers, of course, because that's how you pay the bills in academia. But we also build live, interactive, data-driven tools and services. And everything we build is open source. We had about 70,000 lines of code online before the pandemic hit, building things like the trialstracker.net, which lets you see who is and isn't reporting the results of their clinical trials and who's complying with the law in Europe and in America. Things like openprescribing.net, which let you see what every doctor in the country is prescribing, down to the level of individual doses and brands of individual drugs in individual practices in individual months. And that's got about 140,000 unique users a year now. And at the beginning of the COVID pandemic, we had this sudden realization that the current systems and frameworks for working with NHS electronic health record data were not going to work to evaluate the risks and potential treatments for COVID-19. So working on behalf of NHS England, we've now built a full open source, highly secure analytics platform running across the full pseudonymized electronic health records, primary care of 58 million patients. And that's a huge collaboration. It's across my group at the Data Lab at Oxford, the Electronic Health Records Research Group at London School of Hygiene and Tropical Medicine, the Electronic Health Records software suppliers in primary care, so that's TPP and EMIS, giving pro bono collaboration. And then lastly, close collaboration with NHSX and with NHS England, who act as the data controller. And we're delivering work on COVID risk factors, including factors associated with COVID, which drugs are associated with higher or lower risk of COVID, the relationship between ethnicity and COVID, following up COVID patients, looking at stroke, DVT, myocardial infarction in people who've been admitted with COVID, work on vaccine coverage. So our work is the reason that people know that Black people are about half as likely to get vaccinated as white people. Also a social gradient in who is and isn't vaccinated to date, but also because we've got the very detailed records of so many patients, we can also produce descriptive statistics, which you can find very easily online, showing, for example, vaccine coverage in people with and without a severe mental illness, where we are still the only place where you can see that vaccine coverage is lower among people with a severe mental illness, with learning disabilities and with dementia. And we're also now doing work on vaccine effectiveness and work on vaccine safety as well. So you'll be seeing from us shortly work on some of the clotting stories that you've seen in the news over the last day or two. And it really is an unprecedented scale of data, just to be clear. We've got every individual patient's full primary care record. So that's every diagnosis, test, referral, prescription, linked on for 24 million people, and we can scale up to 58 when we need to. SUS, hospital admissions, outpatient visits, coded A&E attendances, death in hospital from COVID, COVID test results, ONS death certificate. We've got household variables, so we can tell for each pseudonymized patient who the other pseudonymized occupants are. We can see, is it a care home, approximate location, see if people have gone to ITU. We've got linkage onto ISRIC, the detailed hospital records of about 70% of all hospitalized COVID patients, and more. Now, this is a really extraordinary scale of data. It's an unprecedented scale of data. And yet, despite that unprecedented scale, privacy advocates like Med Confidential have actively praised our privacy model. And that's because of some of the very unusual design choices that we've made. And to understand what we've built, I think you need to understand a little bit about what the normal practice is around working with data. So the traditional approach to working with electronic health records data for research, for example, with CPRD or similar, is that you would download an intermittent extract of the data, a cut of the data, onto your local machine, and the name and address is removed to make it pseudonymized. And then you would work with that to process it up. So it will be 1 row per clinical event, and you'll process it up into a 1 row per patient data set with some variables that are research ready, regression ready. And then you'll deliver your analysis like that. And there are a number of problems with that approach. Number one is it's intermittent data extracts. And so it's too far behind the curve of what's happening in the health service to be useful, especially in a pandemic. Using the normal mechanisms, the first wave of COVID would have come and gone before any of the important data had appeared in any of the traditional intermittent data extracts. Secondly, the way that people do all of their data management is completely non-standardized. And there's a culture of basically build it once for me, and then when my study's done, throw away all the intermediate data management. So the typical story would be, well, you know, Barbara's pretty good at SQL. She'll do you an extract, and then she'll put it on the shared drive. And then, you know, Tom had a PhD student who did something in something called Python. And if you put that program in the same file as that, it'll reshape it. And then if you open that in Stata, you can write a load of commands to make the dates work properly and create some derived variables, and then it'll all work fine. We wanted to bring something a little bit better to the table. So what we've done is, first of all, to preserve patients' privacy, we don't let users download data onto their own machine to work locally on it with R and Stata. And we don't even give direct remote desktop access to an environment where you can see the data. Instead, we've done 2 things. Number one, we've built the analytics platform inside the electronic health record system vendor's data center, where the data already resides. Now, that's really important for a number of reasons. Firstly, it means you've got access to the data in near real time. You don't have to rely on intermittent extracts. Secondly, and this is no small beer, it means that you've got already a very close working relationship with the people who write the software that creates the data in the first place. Now, that's worth its weight in gold. This is a geeks conference, right? Like, there is nothing like, you know, if you want to know why long COVID codes are or are not being entered into the record, and we're about to publish something on this, you want to talk to the people who build the machine that allow doctors to put long COVID codes into the records, because they'll be able to sit down with you and, you know, you'll be telling them sometimes things they don't know. And it's the real A team. It's the ultimate, right? You understand how to process data at scale for research purposes, and they understand where it's come from, its provenance. And that's been a fantastic experience working with TPP, where work's much more advanced, and also more latterly with EMIS. It's been absolutely brilliant. I mean, you know, it's been the most exciting project of our lives, I think. It also allows you to keep logs of everything that happens. But it's not the only architecture choice. The second, I think, is much more interesting. We also impose some pragmatically flexible, but broadly speaking, standardized approaches to the data management pipeline. The translation from the raw underlying 1 row per event data into a regression-ready data set. And from that, 3 or 4 really important things follow. First of all, it means that all of our variables are readily reusable and they're understandable to everyone. So the way that you convert a 1 row per event data set into a 1 row per patient data set, the way you convert a list of SNOMED codes describing a particular prescription or a particular diagnostic code or a particular blood test into a variable called has diabetes or has mild rheumatoid arthritis is done in a standardized way, which means that everybody else can see it and reuse it. And that's really crucial because, well, firstly, I mean, I hope you take it as read, but let me be very clear. Every single line of code that we've written for OpenSAFELY is available free online for review and reuse under MIT license. It's about 37,000 lines of code to date. If you go to github.com/OpenSAFELY, you'll see the whole thing. And not just the code for the platform, but every code list for every variable that's ever been created, the full pipeline, and also the code for every single analysis that's ever been done in the platform. So this is transparent for a number of reasons. Firstly, because of the efficiencies around reuse and review of code, which I think everybody here is a beast for already. Secondly, it's also really important for reproducibility. We know for a fact that often people have little gremlins in their code. And if you can see the code list and the code, then you can sanity check it. You can understand what's going on. It's also really important to understand the differences between different analytic approaches. So it's quite common to find that 2 different studies in the same source data set, for example, CPID, the GP research database, 2 different studies will address the same question, but come up with different answers, sometimes slightly different, sometimes completely different. And usually there's no way of knowing whether that's a slight difference in source data, a difference in data management, a difference in the statistical model that's fitted, or error, or actual operator error. Whereas with OpenSAFELY, you can see absolutely everything, the full journey.
So you're sharing the code, but not the data.
Exactly, we share the code, but not the data. Yeah. Now, secondly, you mentioned not sharing the data. This is where things get really interesting. Okay, so because we have control over the pipeline, that means we can also share, secondly, readable and intelligible logs. So if you were trying to share logs of just somebody's normal, if you were trying to share logs in a kind of completely general purpose, unstructured environment where everybody implemented their data management in whatever way they fancied, you would have, I mean, I don't know what you'd even do. I mean, you might keep a log of every SQL query. I mean, where in the system would you even sort of plug in and listen, right? Whereas with OpenSAFELY, if you go to jobs.opensafely.org, you will see live, and go and do it now. There's nothing interesting to see here. If you go to jobs.opensafely.org, you will see every single job that is currently executing against English patients' data live. And you can see the full history of all the things that have gone through as well, back to when we first built the jobs server. So we haven't shouted about this in public yet, but I think it's performant now. I think it's complete. For each individual job, if you click on it, eventually you'll get down to the GitHub repo and the commit ID, which will show you exactly what's running against the data. So these are the most explicit logs you could possibly hope to see. And because the data management pipeline is standardized, you can understand what each project is doing, and that's really important. Some of the GitHub repos you'll find are closed, and that's because our general policy is, and you can read, if you go to opensafely.org, there's a link to the principles of OpenSAFELY. You can see that we expect GitHub repos to be made open at the time at which the results of the analysis are shared, which I think is proportionate and realistic and reasonable. So that's the second thing that flows nicely from imposing these standards on the pipeline. But the third is really, really interesting. Because we're in control of the whole pipeline and we know what it is that you're building and how, because you're using our standard tools to convert the raw 1 row per event data into a 1 row per patient data set. That means we can generate dummy data that reflects the real data just about well enough for code development to be done in the open. And this is really important. People talk a lot about synthetic data. And the ambition for synthetic data that I think is basically unrealistic is we're going to take the real data, we'll take the names and addresses off, we'll add random noise enough, we'll permute it enough that it still preserves the relationships between different exposure and outcome variables for your analysis to get the right answer about whether ethnicity is associated with death from COVID or whatever your clinical question is. But we'll have introduced enough noise that you can no longer identify an individual in the data set from what you know about them, because that's very easy to do. That's the disclosure. You take name and address off a data set, but I can still find Tony Blair in HES, the hospital episode statistics, because I know what year he was born in, and I can go back and check in the newspaper archives the 2 weeks in which, while he was Prime Minister, he went and had his abnormal heart rhythm treated in an NHS hospital. That's enough to identify Tony Blair, and having identified the pseudo ID of Tony Blair, I can then look to see if he's got anything that he might prefer to be kept secret. And so the fatuous example of that is, did somebody have chlamydia? But actually, I don't want to shame people for STDs, but people are entitled to want their medical record to be kept private. So the promise of synthetic data is you can permute it enough to prevent re-identification, but not so much that it destroys your analytic output. I think that's optimistic. It's hard to evaluate whether you've protected privacy, and also it's unnecessary. What we do, I think, is much, much cleverer. And this is like the whole team, and Seb Bacon, who's in charge of our software, is a god among humans, as is everyone. I mean, it's the dream team. I love them all so deeply. There should be a special word, I bet there is in German, for the profound romantic affection you have that is, to be clear, non-sexual. But the profound romantic, affinity you have for people where you've embarked on such a big project and you've just killed it and you've got such a shared vision. God, it's been so good. Maybe I'm over time.
I just want to ask you that, Ben. If you hadn't set up the data lab first, so we talked about this before about funding teams, not projects. This wouldn't have happened, would it? You were ready to go, so
we weren't big enough, and everybody should always have given us more funding. But the absolute key to this was that we've got software developers who know about how medicine works, how electronic health records work, how the health service works, how epidemiology works, and we've got researchers, including clinicians, who know how to do a pull request, who've got Docker installed on their machine, who do version control and unit testing and code review and everything else. They can work as in using sort of modern, open, collaborative computational data science techniques. Our researchers and clinicians think a lot like open source software developers, and that's how we were able to do this. And
you don't need you don't need outcomes. You don't need something to write to it. You don't need to get your outcomes signed off before you start.
Well, it means that you can trust everyone in the team to work out how to fit in and how to interdigitate. I mean, now we're growing. There's some interesting questions around how you grow, also particularly around how you spread these working practices. And the whole point of building OpenSAFELY actually is to try and spread open working practices like a virus. So we now have a pilot onboarding program for external users. If you go to OpenSAFELY.org, I haven't advertised this because it's basically full and we're overrun. But if you go to OpenSAFELY.org, at the end of the first paragraph, you can see a link to where we talk about how external users can apply to come in and work with us as collaborators. But let me just finish, and then I promise I'll stop.
It's okay.
The story of the most important privacy engineering move in the system, which is because we know the shape of the data set that you're going to create from the real data, because you've used all our standard data management tools. And because you tell the system what you're expecting the prevalence of diabetes to be, or what you're expecting the average blood pressure and the range of blood pressures to be, you assert to the platform what you're expecting of your data set, and your data management code in OpenSAFELY produces two different things. Number one, it makes a dummy data set that's completely non-disclosive, completely randomly generated. It can respect the co-segregation of different variables with a directed acyclic graph if you really want to destroy a few days of life, or you can just make it really simple. But it's non-disclosive, so you download it. You can work with that locally or online if you want, using GitHub Actions and stuff like that. You can develop code against it in the open using R or Stata or Jupyter notebooks. You develop all of your code on GitHub. And only when it's passing all tests, you've got all the green lights, you know that it's capable of running to completion. You haven't called a variable that doesn't exist. You've left a comma out of your analysis script.
So the data you're using looks and feels like the real data, but it isn't.
It looks and feels like the real data.
It's the same size, it's got the same column headings, it's got all the same stuff.
Same column headings, same variable types, everything. Because the idea is to avoid a world where you have to log into an environment where you've got naked access to the raw data and you're tinkering. We don't want people to ever go anywhere near the raw data. No, not in any setting, not even a remote desktop. And it's infuriating actually the way people talk about trusted research environments. And you go, so what is your TRE exactly? And basically they put their nan's laptop in a rack, and just because they remote desktop into it, they think it's a TRE. We didn't want people to have to tinker at all. So you get all your code to the point where it's performance capable of running to completion for your data management and your data analysis. And then and only then, when you're happy that it's going to execute, you press a button, your data management and data analysis code gets wrapped up in a container using Docker. That then gets pushed through into the live environment where it executes against the live data, and you are never in there. No researcher ever needs to go into that live environment where the live data resides. It runs to completion because in Docker, the machine that was previously on your machine thinks it's in the same place. It doesn't know that it's now connected to a database that's got the real data in it. It executes to completion. It dumps your output graphs and tables and logs into an outputs folder. You log in and you make sure that there's no small numbers in the tables or whatever. And then when you're satisfied, then that gets released back out to GitHub, to the same GitHub repo from whence it came, and then you can see it. And that, in short, is OpenSAFELY. And the implications of this are phenomenal, I think. First of all, it's fully open source, it's fully transparent. Everybody can see a full log of everything that's happening. Code is shared for data management and analysis by default. There's no way around it. No researcher, either for rent-seeking reasons, cache-chasing reasons, or just laziness, can leave their code undisclosed. It is all by default on. It can only execute against OpenSAFELY via GitHub, and it has to go public. And we log everything. If you don't make it public, we've got a copy of it. You know, it's going public. That's that for everything that you do. Secondly, it's curation as you go. So this is really complicated data. Makes me a bit angry when people say, oh, GP electronic health record data is messy or dirty. It's not. It's perfect for its intended purpose, which is an aid memoir to help a clinician manage a patient and to help clinicians and patients manage their problems together. When we want to convert it into a research data set, it's challenging. But each variable that you create, like an ethnicity variable from all of the different ethnicity codes, different ways of creating a diabetes variable, they'll all be bespoke for a particular analysis, but a lot of them will be the kind of thing that you might want to reuse. So why not reuse them? So we've got this growing library of variables. We're creating the commons of knowledge that should always have existed. And there's been this catastrophic strategic failure, in my view, for health data research in the UK, where we've had everybody working in the dark behind closed doors. We've had money go off to closed commercial systems that there's nothing wrong with commercial outsourcing, but you've got to be a good customer. And we have not been good customers historically because we haven't been able to see the code. We haven't created a commons of knowledge. And I'm not a fan of open because I'm a hippie or a communist, because I'm frankly neither. I'm in favor of open code because I want a commons of knowledge. I want the NHS and the research community to be able to learn about how to manage that data so that we can do good things. And I believe that the network effects that you get from having an open commons of knowledge around that data and how to manage it will create a whole packet of both public and private value for the UK. And, you know, history's on our side for that. And I think that's the transition that we're going to see. So that's OpenSAFELY. And, you know, out of it, we've got a Nature paper, a Lancet paper, a BMJ paper, all the normal papers. But we've also got an open code repository for the first time ever, finally, that anybody can use and reuse, and it's portable code. You can, it's not as simple as sudo install OpenSAFELY, but if you want to start trying to implement OpenSAFELY locally against your own data sets as well, then we're happy to talk about that too.
Fantastic. And so we talked about the fact that you had a team ready to go and you'd invested in that, and the investment of also a TPP and EMIS, and that they were really important. And ODI leads, we know Chris Bates and the TPP team really well, but the question I've got is, so what happens now? Because surely no major program in the UK can't follow your lead. And how do we prevent people going backwards rather than going forwards with your work?
Look, you can shout at people when you don't like what they're doing.
Yep.
And I've done that here and there during my career. You know, I wrote a column in The Guardian doing that for a decade. And I think that has its place. What I hope is that so leading by example is a bit pompous. That's partly what we're aiming to do with OpenSAFELY, but we're also aiming to create tools that make it easy for people to do the right thing. So there are a lot of competing things. It's an interesting challenge to the system, I think, also to transition away from old methods of funding and reward as well. There are a few kind of conceptual understandings in the system which are completely understandable. Like, well, firstly, a belief, and actually I was really pleased with UKRI's most recent work on digital infrastructure, which was published a few months ago, which actually for the first, well, does not make this mistake, but there is a prevalent view that infrastructure means buildings and beige boxes and a big concrete thing that fires particles around a donut. When it comes to data science, infrastructure means people with skills in teams that know how to work together, and it means code on GitHub. And that's quite intangible, but that's the reality of data science infrastructure, and people really need to understand that. If you want to resource that, then you have to resource essentially the creation of intermediate objects in the pathway. So traditionally, the approach is we're going to fund a thing and it's going to produce a paper in the Lancet. We've kind of hacked that system because we produced a paper in Lancet, Nature, BMJ, but along the way, we've given away as an exhaust product all of the intermediate stuff. It is still impossible. We have still never had any money from any state agency at all for OpenSAFELY as a platform, as an open source platform, and as a platform for other people to use. We've had money from UKRI, MRC, NIHR to do individual research projects ourselves. It's this peculiar paradox of actually we want to do something much more pro-social and much more impactful than that, which is to give it away. We haven't been able to do that. I'm very hopeful that we'll be able to change that, but it is undoubtedly a strategic failure for health data research in the UK that there is not somewhere where you can ask for that kind of thing. However, Wellcome, I'm very pleased to say, in November signed off and gave us a special award. So it was kind of bespoke, an arrangement for us to have some resource for the core team to keep it going. So there's a challenge there, just to use our example as one instance of the broader battle. I think we need to find a way for the state to say, we will resource these intermediate objects. And actually it's a problem that's very limited to health data research. That's the really interesting thing. So firstly, if you look at the gene and molecule characters or the physicists, they're actually very good at creating open shared infrastructure and sharing all their code as open. I think part of that derives from the fact that they don't have information governance challenges around the underlying data. I think there's something about the disclosure risk of the underlying data, either by a sort of misunderstanding and transferred epithet. People go, well, I can't share the data, so I better not share the code, which is obviously mistaken. Or less generously, maybe in some cases, it's an excuse. Or maybe it's an accident of history. But either way, the molecular and gene people, they share code. That's routine. So you can see that it is possible to do it. I think also intermediate knowledge objects, which is a horrific phrase that I've just concocted because I'm talking to people who are developers. But intermediate knowledge objects, right? In other bits of science are accepted. So you don't say, you can publish a paper about a reagent that's part of a whole sort of complex ecosystem of actions that ultimately lead up to a cure for cancer. You can publish a reagent or a characterization of a molecule or a gene. There is something very peculiar around computational data science where nobody goes, oh, there's an open funding call for managing data and curating data to transform raw 1 row per event data into regression ready variables, or creating and developing and evaluating and implementing trusted research environments, or helping people who are quite good at writing repetitive code patterns to learn what a library is, what a package is.
Yeah.
Teaching people about unit testing and code review and learning how to do all of that stuff, and creating a kind of computational data science ecosystem. So I think we need to find a way to help funders learn how to resource that kind of activity. But I think it needs to be in a very hands-on way. It can't just be throw 1, 10, 100 million quid into a black box and hope that it happens, because we've sort of tried that in ways that we needn't discuss. And it didn't really, it always delivers some good outputs, but it definitely hasn't worked to meet those objectives. So, the short answer to your question is, if you want great data science to be done, it has to be done in the open. It has to be resourced openly and competitively, and it has to be directly resourced at all. You cannot expect that it will just happen. You have to make it a foreground proper activity. And I think we're going to win that argument. I think, and I think OpenSAFELY has been an important part of proving the case. But I think there's also a huge amount of pent up demand across the system. There are loads and loads of people now who work in electronic health records research, perhaps more skewed towards younger researchers, but who understand this way of working. And I know that because they're the ones who get in touch and apply for our jobs. We're advertising, come and work with us. Wait, have you got, I'll post it on, it's my most recent tweet. Come and work. If you know anything about health and you're at this event, you should apply for a job with us. You're the right.
We'll put that in the chat then. But we're going to close up. But it's great for you to join us today, and it's been fantastic. And I think you're right about winning the argument. Right at the start of the pandemic, we used to get maybe a call every day about people asking us, have you got the data? The data about the thing we're really interested in. And we say, well, have you invested at all in getting that data ready? And say, no, you've got it in, almost expecting us to have it in a plastic bag under our desk that we can just give to answer the question. So, but people have stopped doing that now, and they do understand that good data needs investment and curating and different types of people along the way. So that's, I think, I'm hoping we're winning the argument. And on Thursday, we've got a session at Open Data Saves Lives, which we've been running with Beautiful Information since the start of the pandemic. 25 sessions, over 1,250 people joining us. Your crowd, loads of data nerds talking about stuff and trying to fix it. So we've got a session on Thursday where we're going to do an open response to your Goldacre review, and then send it over to you. So you don't have to do anything. It's the power of open. We'll just send it over to you.
Please do. And I realised we've bored on, but look, that review, which by the way is really interesting, and I think we're going to produce some really informative and interesting outputs. We've done 110 interviews, 10 open sessions. We've met people across the system, and I must say, with a narrow number of exceptions, a very tiny number, there's clearly a huge appetite for working in modern, open, collaborative ways, and leaving behind the old era of closed analysis, where you build it once for me and then throw it away, or build it once for me and then rent seek against it. And I think also, again, and I have to say this, I think there are huge commercial opportunities for small and large organizations across this whole space for making a whole packet of cash out of delivering open code for data analysis, for healthcare, for service analytics, and for research. But if we don't get people sharing their code, then you get no ratcheting effect, you get no aggregation, you get no commons of knowledge. You just get everyone working behind closed doors, sometimes even point and click. They build it once for them. It takes months and months to get one table out in a paper, and then it all collapses and it's lost like tears in rain. And there was never any need to work like that. But I think everybody across the system really understands that now. or at least most people do. And we've got, I think, strong support from the top across a range of organisations. So I feel extremely optimistic for the future in this space. I think it's going to be great.
Well, let's leave it there with Ben being extremely optimistic and you banning. I think people now might understand when I say being radically open gives you massive surpluses. That's exactly what you're talking about. So yeah.
Do you know what? It's the only thing I would disagree on is I don't think we're radical. I think we're boring. I think we're the conservatives. This is the way to work. This is the norm. It's the norm in every other sector except health data research. Something's gone wrong there, but we can fix it, and we've got huge support to fix it. And it's just boring and normal to share your code. Boring and normal. Molecular genetics.
Boringly open that's what we're going to call it. Yeah.
We want it to be banal to work in this way.
Yeah. Okay. Well, thanks very much, Ben. You're our final talk on Northernlands 3, and we'll see you soon. Cheers.
Nice to see you. Cheerio.
Yeah. Bye-bye.